All right. Hi, everybody. We are at the top of the hour, whichever hour it may be for you in your own local time zone. So we shall get started. So I am Ben Kaduk and my co-AD Roman.
Hi, everyone.
Okay. So we are security area directors, and this is the Security Area Advisory Group. So let's go to the Note Well, which hopefully everyone has already seen, since we are already at the Thursday sessions. But if you have not, please note it well. If there's any IPR that you know about, you are expected to disclose it if you're contributing. We also have our community guidelines and the usual, everyone be nice to each other. So next slide. So here's the agenda, or at least so far. If anybody has any bashing or adjustments or changes they'd like to propose, please join the queue and we can talk about those. And I will give a couple of seconds for that, especially as I catch up on the chat window. But I don't see anyone joining the queue, so let's go ahead and go through to the working group reports. Sorry, let's go to the in memoriam. My apologies. So as you all know and maybe saw at the plenary, Jim Shaw passed away in October, and it's been a huge loss to us. So let's have a moment of silence to remember Jim. Thank you, Jim. We will miss you. And can move on to the working group summaries. So I think most of these we can just sort of page through. We've gotten reports from most people, and I've got my local copy up, so I can sort of sneak ahead. So EMU just sent one, which I do not believe made it into the slides. Yes, but that is available. And if anybody has any additional comments that they want to make about what has been going on in their working group, by all means, please join the queue. Don't wait for the particular slide to come up. We've got a pretty good response rate through the different groups, although there are a handful that did not meet and also did not send reports. So it looks like Sec Dispatch, we had the session on Monday, and we had just a couple of presentations. I don't know if anybody does want to come to the mic and talk about Sec Dispatch particularly, or for any of the other related work. I know.
Yeah, thank you to the working group chairs, by the way. I mean, this is a record turnout in terms of having these reports before SAG.
Yeah, and we even got one from like DRIP. I remember seeing.
DRIP, UDA, even OpenPGP. So really much appreciated. It's great to have the status kind of during COVID times when we're all remote, just understanding what's happening.
Yes, just to get a reminder of where things are, even when we can't be together in person. So I did want to ask, is the Model T program, did anybody want to speak to that? I don't know that there's been a huge amount of activity, but that is something that is certainly on the radar of Rowan and myself. I have to scroll through the participant list to see who all is even in the room. But, I guess we do not have anybody to speak to that particularly, so let us move on to the next slide. So to give some highlights, I think much of this, at least in terms of which items are on the slide, has not changed since 108. I do still have a couple of AD sponsored drafts that I'm working through. I know Fernando has updated the numerical ID security considerations actually a couple months ago, but I just got back to him yesterday. So that should be ready to go out for IETF last call. And then the security TXT already did go through IETF last call and got a significant volume of comments. I have attempted to go through them and try to extract out the technical bits and work with the authors to make changes to address them. But I still have to do my final pass to sort of go through the actual changes in the document to see whether or not the review comments have actually been addressed. So that's still sort of waiting for my additional review and follow-up, and potentially would either have more changes to the draft or potentially go to the ISG, depending on the results of that work. Roman mentioned OpenPGP already. We do have the rechartering or chartering process in progress for that. And so that will be going to the ISG again in December, if all goes according to plan. And I do also have a call out for anyone who would potentially be interested in being a working group chair for ACE. We do have a opening there since Jim has passed. So I plan to be making a decision about that next week. So if you think you might be interested, even if you're not sure, please reach out to me and we can talk about what it would entail and whether it's a good fit. So that's security area highlights. Non-working group stuff.
In addition to the ACE working group chair opportunity, in general, if you are interested in being a working group chair, opportunities like this kind of always come up. And so if you let us know in advance, we'll keep you in mind when these opportunities do present themselves. So really kind of do let us know if, with a short note privately, just say, hey, at some point I'd be interested, and we'll see whether there's a match.
Yes, we do always like to have many people to consider and get people opportunity.
A couple other area highlights. We've had a lot of discussion in recent weeks on various vulnerability disclosure guidance. So we first had the discussion about the LLC. So we have a published policy for the IETF infrastructure. And very much most recently, which was, I think we closed it early last week, we also have now documented how we do vulnerability disclosure in the IETF. You can read that GitHub link there, and that should be posted relatively soon to the official website. The big kind of addition beyond everything that we already do was first having it written down, but we now have a last resort alias that will go to Ben and me if that discoverer or that seeker of the vulnerabilities can't find the right working group. The other thing Ben and I wanted to plug is we keep a working list of what we call the common discussed topics. So if you're working kind of on a document, or if you are reaching out in helping with security issues in another working group, we have this working kind of tick list of things to consider beyond all the official documentation we have as documents go forward. And if you have suggestions of other things to add to that list, we also really do welcome that. It's a living document. The other thing Ben and I wanted just to quickly highlight, our pipeline grows and shrinks, and we've been really putting in a concerted effort to make sure that we're working kind of the documents as fast as we can. We know that we are a gating function to moving that forward. So we just wanted to highlight, we've been pushing hard, and we believe everything is through PubRec as of these kind of screen caps a couple of kind of days ago. And what we'd also kind of call out is that our reviews of these are kind of agile. If you have a document with us in the pipeline we would typically probably handle it first come, first serve. But if you have some constraints where you think there are dependencies on the documents, the way the authors have resources requires that we look at something kind of sooner, please don't hesitate to help us reprioritize our queue, to help us know what's important and, again, what needs to get done. And we're happy to look at things, look at things in a quicker way or a different way to make sure that it meets those constraints we may not be aware of.
Yes, I just to second that, it is very helpful if there's a particular document that has some additional constraints. We're both happy to try and work to meet those, but we have to know about them in order to do anything. And just to sort of reiterate that the publication requested queue has gone to 0, but it used to be quite large. So there's a little bit of a bulge that's making its way through to the subsequent states. The 80 evaluation, last call, and waiting for the write-up, but we are working to keep those queues short as well. So it looks like Ira is in the queue.
That I tried to send a couple of chats, but they went into space and the chat window remains empty, and I think it's broken.
I believe you can reload the page and hopefully the chat will. After you ask your question.
Okay, so my question that I typed twice, but I'm not sure that it got into some chat window, was is there a second working group chair for CBOR to follow but not replace the irreplaceable Jim Schad and help Francesca? CBOR is rather active.
So the CBOR group is not in the security area, so
that's why. Okay,
not exactly our problem, but I do believe that there is work to get an additional chair for CBOR as well.
Thanks, Ben. Question.
No, it's a good question. Okay, so I think that we can go to the. DKG is also in the queue.
DKG in the queue.
My apologies.
Hi there. My audio.
You are pretty quiet.
Yep. Is that better?
Much better.
Great. Amazing what the volume knob does. I had a question about the security vulnerabilities disclosure. Just a logistical question, which is, I note that there is an OpenPGP certificate published so people can make confidential disclosures to that catch-all address, but that is not published on probably some of the most popular key servers, and it's also not published via WKD. So I'm just wondering whether there's any plan to publish that in one of these standard lookup locations to facilitate automated finding. I'm happy.
Absolutely. If you'll notice, the write-up of that is actually still in GitHub. We have not yet done the necessary steps to put things on the website kind of itself. Publishing the key in one or many kind of key servers is still one of those last steps we need to do, in addition to a little bit of editorial polish we still have. So that's on the tick list before we launch.
Okay, cool. If there's questions about how to publish and you want to reach out to me, I'm happy to try to work with you on that.
Absolutely. I really appreciate it. Thanks for the reminder.
Sure.
Thank you. Okay, now the queue is empty, so we can go to the next slide.
So Ben and I just really wanted to reiterate, while we do a lot of document review, there's a tremendous amount of magic and effort that happens before things get to us, and things that happen that tremendously also help us. And that's only possible through the sector review process. Folks on that team give really of themselves, and they shoulder quite a heavy burden to do either last call reviews. They are there for the telechat reviews. They are the resources we have when working groups want an early review and do that iteration. And it frankly makes the document quality by the time it gets to the ISG so much better. and we can't thank that team enough for what they do. And so we just wanted to quickly publicly recognize all of the reviews that have happened and who those reviewers have been since the last time we got together in IETF 108. So again, really kind of thank you everyone. You're really helping us in the community.
Yes, a huge thank you to all the reviewers, and I think we checked pretty hard to make sure the list was complete, but if we, by some accident, left your name off, we are deeply sorry, and we do thank you as well. All right, so the next agenda item was this sort of terminology question about on path or man in the middle, and what does this actually mean? So if we go to the next slide, this was a thread that was actually that was started on Saag by Michael Richardson, and so I've got the link in the slides to the initial message of the thread, and then Michael also tried to do a summary as well, probably a few days ago at this point. The days are blurring together. But to sort of reiterate some of that, if we go to the next slide, to reiterate some of that for this audience, there were a few interesting points. So obviously, many of these terms that we bandy around don't actually have a precise definition. Man in the middle has been used for probably decades, and sort of the landscape in which we try to use it has changed around us. So we don't necessarily always have a clear agreements on what we mean when we say that, and that can be harmful when we're trying to have specific technical discussions. And it also came up that even the notion of being on path is a little bit malleable or fungible in terms of what context you're talking about being on path in. And then there's the sort of meta point that the path itself could be subject to attack or could change over time. So if you could be on path only some of the time, then that's another consideration as well. And of course, there's sort of this overarching point about, well, how much do we really care if we should be trying to design against the strongest attacker that we can imagine? Well, that's not strictly true, but if we're trying to design against a very strong attacker, then the notion of on path or not is in some sense irrelevant, because we want to protect against it no matter what it is. But there are, in fact, some cases where having this sort of distinction between different classes of attacks is useful, in that we can sort of be able to discriminate when one thing would be a problem or when it would not, and to be able to talk about the distinctions versus just there's an attack and there's not an attack. There can be a lot of context around that in terms of how severe it would be, or in what cases it would be problematic. So next slide. And to sort of continue the theme of summarizing the list discussion, there was a couple of different taxonomies that were proposed or repeated. So in quick, there's the on-path or limited on-path that can't delete messages, but can preserve them, and then the sort of classical off-path attacker. Or you could have somebody in the middle, on the side, and the rough for roughly the same sorts of things. Or if you like your alliteration, the malicious messenger, oppressive observer, and chaos creator. But if we go to the next slide, there's sort of some questions about, are these really a useful taxonomy to have? Like, is there more detail in what's going on that we need to have terms to be able to talk about? And of course, the pervasive question, the theme of this talk perhaps even, are these terms well defined and unambiguous? Like, are they useful when we need to have specific, precise discussions about what the status of the protocol is? First off, if anybody has an immediate response to either of these questions, please go ahead and join the queue. This is not supposed to be me talking to you all for the whole time. It's goal is to have a conversation. So Paul, please go ahead.
Greetings. So we're having some of these same questions in Deprive right now. So I would be willing to edit a document as long as I was not the person deciding consensus. This is obviously full of bike sheds, as we saw on the last slide. But it is real. I think it would be very important for the IETF in general to have a small set that are usable currently across working groups. We've had old definitions and such like that, but I think doing something and trying to finish it within the next 9 months or a year would be really useful to a few working groups. So I'd be willing to edit as long as maybe Ben and Roman would be the ones who were deciding consensus and such like that.
Okay, I mean, glad to hear that you think a document would be useful in this space to really sell things down. That was even not something I was sure about. And thank you as well for the offer to edit the document. Jonathan, please.
I think this is the kind of thing where we should just look to academia. I'm sure, or I can't think of a particular paper right now, but I'm sure that there are very comprehensive taxonomies, and just limiting it to sort of 3 levels of attacker is not particularly useful, because especially, at least with the TLS analysis, we're also assuming an attacker that can compromise some subset of the participants in the protocol, at which point you're going to have, you know, it can get much more complicated than 3 layers. So I feel like this is just something we should punt to academia.
That's a good point. Do you know if you or yourself or maybe somebody else might be able to take some time to go look through the literature?
I'm happy to go look through the literature.
Thank you. That would be quite helpful. And presumably the results of that can be input for Paul as we try to prepare a potential document for specific usage in the IETF to sort of summarize what we found from the literature. So Jonathan, I assume you're done, so you can leave the queue. I don't think I have the option to do that. Joe?
Hello. So
Hi, Joe.
I'm wondering if this is something that would go along with the Model T work. It seems like description of attackers might be in scope for threat modeling.
Yeah, that was another question that was not really clear to us in terms of the actual model itself versus the terms to talk about it versus the terms to talk about the model we currently have. So it's probably something that Model T could or even should be thinking about, but we may want to have a terminology set that's useful for us even before the Model T work has finished. Okay, so Jim is up next, I believe.
Hi, I guess you can hear me. I see the little bar there. So I'm a little bit confused about what problem we're actually trying to solve here. Is this a question of inclusive terminology, or is this an issue of, I thought that was kind of where this came from, but it seems like there's also an issue of trying to come up with a more a finer grained definition of what an in-the-middle attack is. So I guess I'd like to understand that, and if it's in terms of the inclusive terminology, there's also this other work that's going on in the IETF terminology GitHub repository, and I don't know exactly who's managing that or what working group or whatever is dealing with that, but that's going on as well, and I'm seeing that cited externally. Okay.
Just a administrative note. I do have, I think, 1 or 2 more slides, so I will cut the queue on this slide, and we can go, we'll drain this queue and then go on a little bit more. To answer Jim's question, now the primary problem here is that when you say man in the middle, not everybody is thinking the same thing, and we would like people to all be thinking about the same thing for any given term. So we just want to make sure that we have accurate and precise terms that everybody knows the meaning of. Any sort of inclusivity would be a secondary effect. So Jim is not sending anymore, so I think that we assume that answers his question. John, you are back. Jonathan?
Just relaying from Jabber, Mohit puts, if we are going to work on taxonomy and terminology, is it worth revisiting RFC 4949?
That is an interesting question to consider. I am going to propose that we punt that to the email list because I at least was not prepared to talk about it right now. But thank you for relaying from Jabber. So Hans, you're up.
Hi. I wanted to suggest that if we come up with some new terminology, that it actually can be used also in some formal analysis. I think it would be unfortunate if we have all these different terms, fine-grained terms, and then there's no equivalent way to use those in the underlying formal technologies for formal analysis, because nowadays we use them more and more often, so there better be some mapping between those.
That's a very good point. I hope that the academic literature is framed in a way that would be consistent with that, but if we get some results back from that search, we can definitely keep that in mind as well. Okay, lost the cues. Jonathan, actually there's Paul back.
Paul's back.
So yeah, just a quick answer to Jim Fenton. The other reason why having good terminology is important is not just so that we in the IETF, especially in security, understand it, but people reading papers that we write about our protocols do as well. And a very good example is in a paper that I've written recently, I used man in the middle, machine in the middle, attacker in the middle, and got some interesting responses from security novices, but people who understand the internet. One is with man in the middle is they said, well, does the person have to be sitting there watching all the time? And so, you know, clearly we should make whatever that phrase is going to be clear that it's not a person, you know, which is a completely understandable thing. But the other is, and this has come up a lot with the questions around DOE, is it's really not in the middle. Almost all of these attacks are very, very near one edge or the other. And so, I mean, it probably was in the middle 20, 30 years ago, but now most of the ones that we are concerned about are in fact, or no, I shouldn't say most, but many of the ones we are concerned about are in fact very near an edge. So saying in the middle hides some of the attacks that we actually care about, namely system administrators putting security busting proxies near users.
That's also a good point. Okay, so I think I said we would drain the queue on this slide, and then there's a little bit on the next slide as well to sort of dig into perhaps a more detailed or finer grained taxonomy. So this, I think, was mostly just summarizing what had already been sent on the list, maybe a little bit of brainstorming from me as well. And I just want to make sure that we had the slide up to see if it would prompt any further thoughts from anybody in terms of triggering new ideas. But I think we seem to be getting some general support for doing something in this space. We will want to not do it in isolation from the work that Malti is doing. There's some other considerations to take into consideration as well. So this is actually the last slide. So the queue is open again. Sorry for the strange split with the question slide. But I think my overall takeaways here are that, yes, it's sounding like we do want to have a more fine-grained, more precise set of terminology that we can use. And there's definitely some constraints on how we should do that to make it most usable for us and for others. Okay, Bob is in the queue.
Go ahead, Bob.
I'm wondering, do we need to make any distinction between peer-wise communications, multi-user communications, broadcast communications, where my focus is right now? Do we need to, is that at all a factor in this discussion?
I mean, I think we are kind of at a brainstorming point in the process, so we're not even starting the discussion yet. So I think it's perfectly reasonable to consider if that should be part of the discussion as well.
Okay.
Roman, did you have a point you were going to
I
say?
just wanted to reiterate two of the other constraints we heard in the discussion from Jabber. I think Mohit was saying, we should make sure we stare at the written guidance we already have in the IETF. And Jonathan noted and Hannes reiterated the idea that the academic literature may also have kind of things to say, and we want to make sure what's there is consistent, and we make sure we don't publish something that conflicts.
Sounds good. So just one more sort of logistical question is if we are happy to have this discussion on SAG itself, or if people think it might become too high traffic and we should split off a dedicated mailing list for that. I don't think we have to answer that right now, but people can probably leave their thoughts in the Jabber or on email, and I guess Roman and I can take an action item to maybe cycle back in a couple of weeks and try and actually kickstart an effort to work on this topic. So queue is empty. Catch up on chat. Okay.
Yeah, there's a robust discussion kind of happening there, but no opinions on where this goes. Yeah.
Yes. So I think we should move on to the invited talk. So I believe I saw Ryan in the participant list. So Ryan, I think you can just go ahead and start sending audio and at your option video as well.
I shall do that. All right. So hopefully this is working. I see the blue bar moving.
Yes, we can hear you. So please go ahead, and Roman's driving the slides. So.
All right, perfect. Well, thanks for having me. I will give a warning here. These slides are packed dense. My intent is not to go over them. But if you find me exceeding 0.8 Eckert, please yell, and I will try to slow down. When it comes to some of these topics, I know that many people participated in some of the discussions that I'll be discussing. My intent is to misrepresent things. So if you find something that you don't believe is accurately presented, please do correct me. The only thing I would encourage is, could you save it to the end to see how much it impacts things, well, just to help things progress. So with that, we can go ahead to the next slide. All right, so yes, this talk, it's intended for people designing, implementing, or using a protocol that uses certificates. This is not meant to be the how do you run your PKI for your organization. It's more about how do you run a PKI on the internet. I'm not trying to tell you how to run a PKI on the internet, but I'm trying to share some stories about what's worked and what's not worked. So next slide. Part of where this talk came from was discussion about the use of what colloquially we call the web PKI. And there was some confusion, what's the problem with using the web PKI and what are the gotchas? So this is interesting for you if you're not sure what the web PKI is. You hate the web PKI or you love the web PKI. And there is some implied, thinking that needs to be done on if you think mutual TLS is all that great or it's an easy solution. So we can go ahead and next slide. So I said the word web PKI. I know I have a reputation in that space. This is not about how the web PKI is awesome or how you should follow the model. It's about painful lessons and how you can learn from these mistakes over the course of 2 decades and hopefully avoid them. Next slide. So it's split into sort of 2 parts, an evolution of what I would call the internet PKI and the web PKI, and you'll see a bit more about what that means, and then discussing about how that practically works for requirements for PKI. So you can go ahead, next slide. And I guess I don't need the covers. Here's the next slide. So the first one that I'm going to talk about is the PKI, and I'm calling this PKI 0.1. It's sort of the alpha. It comes about X50988. And the important part to sort of capture here when we talk about what does the X509 PKI, it was part of the directory. You know, it was merely an authentication protocol that fit into the overall X500 series of specifications to describe how the directory worked. It established one right way to name things, and this was the notion of the distinguished name, a globally unique name. That there was one true directory, that it had all the information you could need or want. You could just look it up in the directory. And so the need for certificates was very little. It was merely as a asymmetric cryptographic exchange to authenticate to the directory. And after that, everything you needed would be in the directory. Or if you need to communicate with someone in the directory, you could use it to look up their information and communicate with them there. Next slide. So around this time as well, we saw the evolution of what I would call Internet PKI 0.1. And I know I'm going to bring back some bad memories for folks who were involved in privacy enhanced mail, because this was a very difficult time to sort of figure out how this should work. It made use of X509 certificates, but without the inherent dependency on the directory. The first sort of approach was, as you see in RC 1114, that there was a way to name things, but it was mostly determined by RSA DSI. They were going to run the PKI for everyone, and they would be able to certify what are known as organizational notaries, who would then be responsible for, within the scope of that organization, defining a namespace. Now, not everyone was organizationally affiliated, so for those that were residential, RSA would also run a CA. Now, despite there being organizational notaries, the suggestion was that RSA would in fact run these as well on a practical sense, since running a PKI is hard. In the subsequent privacy enhanced mail RC 1422, it became a bit more complex. The suggestion was that the ISOC, or that ISOC would run what's known as the Internet Policy Registration Authority, which would be the root of trust for the Internet PKI. And it would register policy certification authorities that defined policies appropriate for their communities. And within there, CAs would be determined whether or not they meet those policies. Now, the source of information here, since you're not really using the directory, comes from the message headers. Everything you need is sort of in the message that you get, and you don't need to go through any lookups because it's a very flat structure, right? You have the policy registration authority, the policy CAs, and the CAs beneath them, but you don't really get much deeper than that. Next slide. So around this time, Netscape comes about with SSL, kicks it off in November 1994. I would say Netscape's goal was rough consensus and running code, but they sort of did a sidestep around the IETF because they were concerned it was going to take too long. So they threw up a rough draft spec as well as shipped a very beta copy of Navigator that implemented SSL. And the reason for doing it this way was they were, as reportedly, deeply concerned about what Microsoft would do in terms of bringing commerce to the web. And so they wanted to be there first to ensure that there wasn't a proprietary solution. Another part of this, though, was also that they were aiming for minimal change to existing software. It needed to work on the computers people had with the software people had. And so this largely meant doing things in user land, which is why it became the secure socket layer, no other changes. They used X509 because RSA said to use X509, and that seemed like a good idea at the time. What else are you going to use? And there was very little external dependencies. So in the very first version of Netscape, it merely checked against a list of issuers that were baked into the binary, and every certificate was directly issued by one of those issuers. There were no chains. There were no chains in the protocol. Naming rules, there were no naming rules. In fact, there wasn't really anything going on whatsoever. So in the early versions, there was nothing being checked. The idea is that users would manually inspect certificates and decide whether or not to continue. After they released the specification, Hal Finney of Cypherpunk's fame pointed out that, hey, maybe you should actually check that this was the server you intended, because just because the server has a certificate doesn't mean it's the right certificate. If I have my certificate, I can pretend to be the server. Next slide. So after Netscape came out with that spec, we saw at IETF 33 the secure socket layer BOF. And you saw, if you look through the minutes, you'll find some very exciting statements, such as, you know, if that Eastlake and Kaufman idea works out, which would become DNSSEC, then maybe we wouldn't need this whole PKI thing. And if that IPSP, which would become IPsec, worked out, then maybe we don't need this whole SSL thing. But we need something now, and we need to have it ship, and it needs to be able to work. So we have it, and this became secure sockets layer. Shortly thereafter, at IETF 34 was the first meeting of PKIX. You can find a little bit about the history of why that was. That the work on PIM had revealed that it's actually really hard to use CAs on the internet. There were a lot of limitations. The ITU had proposed a number of changes that became XO 509v3 and particular extensions. Now the goal with PKIX, and I hope I, again, am not misrepresenting anything, was no presumed dependency on the directory, to allow multiple routes without necessarily the ISOC running the route or having RSA run the route, with many ways to name things. There were some important goals that were set out in that first draft that would become many of these RFCs, which is minimal configuration by users, minimal interactivity requirements. Things needed to be able to be automated and verified with automated tools. And boy, golly gee, wouldn't it be nice to have automatable certificate enrollment and management using well-defined protocols. Now that took a number of years from when that work started to when that work was specified. In all the meantime, Netscape and Microsoft were waging a very exciting war. Next slide. So this is where I call web PKI versus internet PKI, this period where the PKI that Netscape had deployed really started off with presumption of user interactivity. They did add the common name checking and would later add subject alternative name checking, but really the assumption was users will be inspecting using the document information. It also had that fun, exciting side effect that if you encountered a CA you didn't know, it would handily prompt you, do you want to trust this CA? Not warn you, but suggest you probably want to trust this CA. The web PKI this time assumed a strong connectivity to the internet. Your client software, you're talking to a server, you're talking to the internet at large. Not to say firewalls weren't popular, but the assumption here in this PKI was you're on a client and you're talking to sort of the broader internet, whereas PKIX wanted to consider very explicitly situations like firewalls and limited traffic. Web PKI was focused on browsers. And it started off that way, but the movement by Microsoft to move IE into the operating system started to create what I would argue is the precursor to the internet PKI. Because they wanted to expose these services as sort of general operating service, or sorry, operating system level services where anyone could write an internet enabled application. Whereas Netscape had started off really focused on the browser. Netscape would add support for SSL to some of their other protocols like SMTP and FTP, but with respect to the communicator product, but this wasn't sort of how things started. And it blurred the lines between the web PKI and the internet PKI, because here's a set of CAs that can be used for a variety of protocols, a variety of internet services, and it just works. Is it supposed to be just for the web? Is it supposed to be for anything? It was a bit ambiguous. And the selection of CAs was admittedly very weak. It was mostly based on organizational reputation and business risk, not necessarily security risk. So you're a bank, you issue certificates, you seem pretty trustworthy because you're a bank. There's a lot of regulation around banks. So that was what made a lot of the early CAs. The audits wouldn't come until later. Next slide. So I'm going to call this the precursor to the web PKI. This is when things started to get really messy. So the CA browser forum coming about in 2006, 2007 started blurring things. CAB forum started because CAs were unhappy that certain competitors were issuing certificates with only domain names. They felt that this was fundamentally the wrong way to do certificates because they had started out with legal names, even though PKIX was really oriented around internet naming. Browsers were unhappy with CAs in terms of just how wildly divergent everything was. So a meeting was held, did not go the way that the originators intended, because rather than forbidding domain validation, what ended up being is development of a new standard, EV. Browsers were interested in combating phishing, Microsoft most of all, with Internet Explorer. And so they proposed this EV standard. And the reason why I call this like Web PKI 0.9 is it developed a PKI that was very focused on user interactivity. And it was very focused on web browsers and web browser specific needs. The semantics of an EV certificate outside of a web browser really don't make sense. Yes, there's some additional validation, but none of that is actually part of the processing model of a certificate of RFC 3280, 2459, 5280. So it's a very application specific PKI. So that's why I'm calling it Web PKI 0.9. And this is where they diverge. Next slide. And so what I'm calling the birth of the Web PKI was when the CAB forum adopted the baseline requirements. So the context here is the CAB forum was created. Some CAs, I should say, were unhappy about domain validation in certificates, created this new EV standard. So now they wanted to come back to minimum standards and figure out what is the absolute bare minimum for certificates. And the work on this, while it made progress, was incredibly contentious and incredibly profane on the mailing list, I will say. And then DigiNotar happened. And DigiNotar happened in 2011, in the fall of 2011, and it really shook trust in the system. And the version that had been circulated that had been quite controversial, which allowed for both domain validation and organizational validation, came about. And it also set up a number of policies for how certificates could be issued, when they would be issued. Most importantly, for example, is the deprecation of 1024-bit certificates was in that very first version. And what it said was that after December 31st, 2013, CAs would no longer issue 1024-bit certificates. And the reason why this focused on issuance was browsers were concerned about backwards compatibility. They wanted to be able to continue to accept certificates that had been issued while making sure that no new certificates were going to have the problem. And so they relied on this by preventing CAs from issuing the new certificates. And that way, they did not have to disable the 1024-bit code within their product until the majority of servers had migrated off their existing 1024-bit certificates. So it was a bit of a flag day in a way for managing that. But importantly, it also marks a point where browsers really began to tell CAs what they can and can't do. And that's why I call it the birth of the Web PKI, because it was an application community defining policies for the CAs and for the PKI. Shortly thereafter, and I say shortly in order of years, another deprecation followed, which was the deprecation of SHA-1, which had a similar sort of sunset date where no new certificates could be issued. And this sets us up for the Web PKI and sets up some of the conflict that I'll be discussing. Next slide. So it would not be correct to talk about Web PKI 1.0 without talking about 2.0. And what I'm calling Web PKI 2.0 is really the point in which people realized that there were in fact separate PKIs, that there was this concept of a Web PKI being a majorly different thing, that it wasn't just about the software verification quirks within browsers, but in fact that there were a different set of policies and expectations and needs in user communities. And so Symantec, largest CA, their history of key material goes back to the days of RSA, DSI, and VeriSign. And I do see some participants here who were around VeriSign at those days, had some issues, and ultimately got distrusted in browsers. But the problem was their roots were embedded on virtually every device out there. Part of that was by design of RSA, which was in the early days, if you wanted to get a license for the RSA patent, you had to include RSA's root key material that would become the VeriSign root. Part of it, though, was also just that's what everyone else was doing. It seems like a good idea. So I call it the split between, because we saw a lot of issues with this. Classic example, of course, is a single web server providing a single API endpoint. You see it there, non-updatable device. Number of major media companies had set-top boxes, had TVs, where they only trusted a few CAs. But all of their users used the same web server, all talked to the same endpoint. And now suddenly you had a conflict. If I have an old set-top box, it doesn't work with new certificates. But if I'm using a browser, it does not work with these old certificates that are being deprecated. And so there wasn't a good way now. And now you had to think about the situation of, I have a single web server, I actually need different certificates for this. And because I need different certificates, I need even different domains as a way to distinguish what certificates to send. The other aspect, of course, was that as part of this deprecation, it was not uniform across all of Symantec. So some operating systems would continue, and still to this day, trust Symantec certificates or trust them for other formats like email. And so this also revealed that different protocols have different PKI needs and security needs. The security issues that affected Symantec as it affects the web PKI, some vendors decided did not affect other protocols, other purposes. And so I call it web PKI 2.0. It's the point where I think many people, I would argue outside the IETF, realized that there were in fact multiple PKIs and brought a lot of awareness here. So I'm now going to jump here to talk about requirements for PKI. Next slide. Actually, next slide. So again, this is sort of the recap on the assumptions here that you're designing, implementing, using a protocol or for a format that uses certificates. Now, why did I mention all of that history for how we got here? Well, the reason why I mention it is that throughout this history, there were various points where we saw branches in approach, branches in need, branches in what was supported. And this affected the design of these different PKIs, the web PKI, the internet PKI, what's capable in software. And these branches have implication if you're trying to use certificates that generally work. And you have to think about what are the answers for this because they have material impact. So an example, next slide, is thinking about the connectivity model. Next slide. Exactly. You can see Kerberos, right? Kerberos has, this is my terribly hacky attempt at the classic Kerberos model, where the client talks to a server, it also talks to the KDC, and the assumption here is that the server and the KDC don't have to talk because the client acts as the mediator. So that's what I mean by the connectivity model. Next slide. X509 v1's connectivity model kind of assumed that everyone was talking to the directory, right? X509 was just a subset of the overall directory protocols. It was how you authenticated to the directory, and you would use the directory to find other certificates. Now, there was the allowance for out-of-band communication, but the idea here is that, say, CRLs would be stored in the directory. If you need to figure out certificate paths, that would be stored in the directory. Everyone talked to the directory. There was strong connectivity, and equally, there was strong connectivity on the client server. Next slide. The web PKI connectivity model is a little messy. We assume that the client can talk to the server, but one of the realities here is we don't assume that the client can talk to the CA. This was realized very early on in many of the web PKI implementations that, in fact, it's really hard to get a packet from point A to point B on the internet reliably, especially from client computers. Everything from local firewalls to dodgy internet connections that you don't really control. So there isn't an assumed connection here from the client to the CA. But there is, to some hand-wavy degree in modern web PKI, an assumed connection to the browser vendor. You need to find out if you have new updates. And so you've probably got a communication channel to talk to the browser vendor. And for the browser vendor, it becomes a point of control in which they can make sure that they have a reliable service. That even if the CA doesn't have visibility into reliability, the browser vendor, because they developed the client, can have a sense of, well, do I actually have a reliable connection? Part of the web PKI also assumes, to a degree, that servers can talk to the CA. Now, it's not guaranteed, though. A classic example of this is sort of OCSP stapling. In order for OCSP stapling to work, we assume that the server has to talk to the CA. And in fact, there's a preference for OCSP stapling because we assume the client can't talk effectively to the CA. Next slide. This is somewhat of an oversimplification, but with PKIX, the 2459, 3280, 5280 design, there's not really any strong assumptions whatsoever. Now, the client and the server, we presume that they have a path for exchanging messages, but everything else is fair game. Whether it's one CA or many CAs, it's a bit of an unreliable connectivity. Now, this is important because in order for many of the security guarantees to work, you actually have to figure out what is the actual connectivity. So next slide. So an example of this, right? The server can't talk to external entities, the client can't talk to external entities, so you have no way to actually fetch or deliver revocation data. If the client and the server are the only two parties that can talk and you have a certificate chain, there's no way to get that. So what's your solution? Well, a solution is short-lived certificates. You don't have to worry about revocation. Now you just let the lifetime of the certificate be what it is. Downside of that is now this introduces into your PKI and your protocol design. You have to think about certificate lifecycle management. You also have to think now about how third-party CAs in that relationship works. If your clients don't have a way to change what CAs they trust, and your servers don't have a way to change what CAs they trust, it increases your risk model of, do you let a third party in on that who you might decide to not trust with? Is it better to bring it in-house? Another example, right, is clients can't talk to external entities, but the server can. So OCSP stapling is viable. There's a problem, though, with assuming that OCSP stapling is viable, which is if the client built or verified certificate path is different than what the server sent, then those OCSP responses the server sent aren't helpful. And in order to solve this problem, you need strict requirements on how certification paths are built so that your client and your server can agree on this is the right path. This means to a degree that you need to understand what your client's trust anchors are or have a way to communicate that to the server so that you can find that mutual problem. I added this to the slide and I didn't realize there was a discussion going on within EMU right now. That was part of what prompted this, but ETLS is this example, right, where you're bringing a client onto the network, they don't have connectivity, and you need to bring them up. And this creates design challenges for your PKI when your client can't talk to the network. A real world example of this, not trying to promote Google products, but when early Chromebooks were released, they had a cellular modem in this. This is the CR50s. The problem with that is in order to use that cellular modem, you need to activate the cellular modem. So you'd go to a cellular provider, in this case Verizon's website, and you would activate your CR50 and you would have cellular connectivity. There's one problem with this. Verizon only allowed connectivity to their servers. They forgot to allow connectivity to Symantec's OCSP servers, and so Chromebooks would fail to connect and fail to be able to activate their cellular connection because they had no ability to fetch the revocation data. And for a brief window, this was a hard failure on Chromebooks. And so it would create, at first, slow connections where it would sit around for 60 seconds spinning, and then also potentially hard fail. And these are terrible user experiences when you just want to use a device. And this affects your PKI design because these constraints change how you design your protocol, your PKI. Next slide. Another thing that is not entirely obvious is thinking about the naming scheme. And so I mentioned the web PKI started out with this idea of show it all to the users. This naming scheme really leaned heavily on the idea of civil legal names, with the idea being that RSA would verify the name for some value of verify, or whoever had the RSA license would verify, and that these would all be trustworthy. So there weren't really rules on verification. With PKIX, there was a strong interest in how do we build something for the internet, right? DNS names. But also with the legacy X509v1, there was the globally unique name, the distinguished name, it's distinguish. However, naming is not so simple. I know I'm preaching to the choir here. DNS, of course, has many zones and can involve many different naming authorities. And you have to decide, how do you reflect that? Is that something that should be reflected in the PKI? There is a model of PKI for every DNS zone split. There is a potential new sub-CA that can allow delegation and control just within that namespace. If you look at, say, the early drafts of PIM, there was a very strong coupling of restricting those organizational notaries to a very specific global namespace, which is the organization, but then allowing them free reign within that. So another way to think about looking at DNS, the web PKI was a global naming scheme. You didn't have to work with the coordination of any of the zones. Any CA could issue for any domain name on the internet. That is wonderful and terrifying. So you can see some of these, but also you have to think about how it means for services and protocols. So I mentioned here, should an HTTP server on port 80 be able to obtain a certificate for your SMTP server? Just because I control the web server doesn't necessarily mean I am in control or authoritative for the SMTP server. And if I can obtain a certificate, can I potentially spoof that connection? And so SRV names could help here. That is certainly one option. Another option, you could put it all in DNS name. You could use extended key usages that have semantic meaning. These are the challenges of the PKI design space because there's no inherently right or wrong way. The answer is it depends. And unfortunately, you can do all of this with the tools the RFC provides you. Next slide. Excuse me. An element of this is whether or not the names are stable or do they change. When RSA originally started this, certificates were 2 years. That was in the contract. And then with PIM, of course, it was able to bring it down even shorter. We can get 1-year certs. The web PKI took a very different turn. Started off as roughly 1-year certs because that's when organizational information could be verified. And both between the combination of domain names and in the combination, the quest to provide ever cheaper services, certificates started getting longer. And by the time the CAB forum came about and adopted the baseline requirements, certificates, there were some CAs issuing 10-year certificates for a domain name. I assure you, domain names don't usually last for 10 years. They can, not usually. When that happened, that took a number of years to get back. Sorry, 1 second. I'm gonna pause and have a drink here. So I mentioned a little here that domain names can change more frequently than annually. We can't just assume a 1-year cert. Research here is like Bygone SSL that looked at how certificates changed. Certificates did not change, were not revoked, even though control of the domain name or where the domain pointed was changed. And so this creates new security risks. So as I mentioned earlier, the web PKI that Netscape shipped that became the web PKI of today really was just a quick hack. The assumption here was get it to market, fix it in post. There was strong confidence that IPsec would replace all of this, as would DNSSEC, and this would just be a short thing. Excuse me, sorry. And of course, this last bit of our names unambiguously interoperably machine parsable. Domain names turn out not to be as clear because you have specifications like RFC 5280 talking about the preferred name syntax, and then you have the running code that allows a lot more than that to hit the wire and actually be resolved with the wire. The canonical example of this is underscores, which a number of products allow to be passed on the wire and are resolvable, even though that's not the preferred name syntax. So are those representable in certificates? And of course, URLs are a special pain point for, I think, everyone involved, and I'm not trying to open new wounds, other than to say that it's not as unambiguously parsable because the real world gets in the way. And when users write URLs, they don't always write them to spec because users are people too. So another problem, next slide, to think about is who can issue certificates. Next slide, exactly. So every zone can be independently managed in DNSSEC, which is fantastic, except for the fact that in order for DNSSEC to really achieve the security you want, every zone has to be practically managed. So there's ecosystem costs there, but it also provides a lot of flexibility in issuance because you can control what is your space. Web PKI, there's a set of CAs that can issue for any domain. Downside, every CA can issue for every domain. Now, I mention this because there is some assumptions that are baked into a lot of the web PKI security models with an assumption that, okay, every CA can issue for every domain, but that's maybe not the end of the world because any client using one of these certificates will also check DNS. And so, yes, a CA could misissue a certificate for, say, google.com, but then an attacker would also need to be on path, be in the middle. I'm not going to try to resolve that discussion, other than to know that the threat model from CAs being able to do that global issuance is slightly tempered by the fact that clients can change how they do their DNS resolutions or potentially their IP connectivity. Will BGPsec and DNSSEC save us? Maybe. PKIX is a very robust model. It allows the federation of all of these PKIs, the mesh and the bridge, and all of these wonderful techniques so that you can be very selective. And you, unfortunately, can get the lawyers involved and figure out how all this works. The downside, of course, is in practice, everyone ends up federating with everyone, and you have no idea who you're trusting and why you're trusting them. And this is practically worked out in the WebPKI. So next slides. Another one is, who's the policy authority? Who decides who writes the rules? This is something that I think causes people the most pain when thinking about web PKI as internet PKI, because why should browsers set the rules? And this is because it is to a degree, browser PKI, for better or for worse. So in order to achieve the security and interoperability you need folks to agree. And this is where SDOs can help, but I think we know that the IETF is a bit shy around policy, and for good reason. So you need a policy authority, and I'm not trying to say that it can't be an SDO, just that in general, it's not an SDO. Because you need to be able to say that X is not secure. And if I say X is not secure and you disagree, I'm missing out on security. And of course, if I say, if I can't say that X is secure, then we don't have interoperability. So there's some issues here to resolve that a policy authority can help cut through in answering whether or not X is secure or not, or be able to work through with multiple participants. I'm going to argue that every PKI needs a new policy, and every time you have a new policy, you really want a new PKI. And so that's a bit contrary to what is possible with an RFC 5280, because you have tools like certificate policies, OIDs, that you can use to express how things are issued. Unfortunately, this is heavily dependent on the assumption of local policy, and we want to get something that just works out of the box. Can't have a bunch of these local policies. And you don't have the ability to discover, say, policy mappings in a very easy and reliable way. And you can't help network effects, because network effects will always penalize the first mover. If you are going to break something, you're in trouble. And equally, if everyone else is breaking something, you benefit from breaking last, because they will have solved all the problems for you. We see this play out in browsers all the time when it comes to like deprecating features. So the policy authority there is someone who can answer these questions, but that is itself a whole loaded question. And as with any sort of matter of policy, but to something that if you want a PKI that works out of the box on the internet between multiple vendors, you have to figure out how are you going to make those decisions and get people to agree, and how are you going to handle when things disagree. Next slide. So a little bit is also to talk about the certificate profile, and I don't strictly mean the extensions. What I mean here, and I make mention here of protocol maintenance, is unfortunately when everything is extensible, nothing ends up being extensible because it's an overwhelming mess riddled with bugs. And PKIX has, unfortunately, because of its history, because of this co-evolution of WebPKI predating PKIX, WebPKI, being a part of the operating system well before PKIX had finished its its final draft, created issues where you have incompatible implementations. Again, thinking about a classic example of this is Internet Explorer not supporting basic constraints. Like, that's kind of a major thing. That was an oops, our bad. But equally, Firefox, Netscape that became Firefox, never supported the authority information access field, even though that's also part of RFC 5280. And so the idea here is that you have to use RFC 5280 as a starting point, but then you have to rip everything else out that you don't need. Otherwise, you will not achieve the interoperability that you're wanting for. So I've listed a few of these examples here. I talked a little bit revocation versus expiration. Well, that depends. What's the connectivity on your clients? Will depend on whether you lean on something like OCSP or CRLs, or whether you have to lean on short-lived certificates. You have to decide acceptable CRL OCSP sizes, which are going to be gated on client bandwidth. If you're using these external lookups, you have to figure out what protocols you're going to support. But equally, say in a web browser, external lookups have privacy consequences that might not be appropriate, where in another protocol, it might be perfectly reasonable. So there's a lot of challenges here. I think, though, to highlight that it's not just extensions. I mentioned, privacy enhanced mail took a very simple flat PKI structure. You had the IPRA, you had the PCAs. So you had this sense of, well, okay, I only have a few layers. You can look at Netscape. with the first version of SSL that they released, which had no chains whatsoever. The length and complexity of your PKI graph is very coupled with how you're going to manage naming authority. Is everyone independent, or is there some central authority, or is there some shared global namespace like the web PKI? This affects a lot of the depth and a lot of the complexity. But then also there are other issues. Let's Encrypt recently published a blog post talking about how their certificates are going to stop working on older Android devices beginning in late next year, September, I believe. And this is, again, something to think about, because the reason that they're in this situation is they don't have a way from a path, a set of trust anchors that are on those older devices to their current certificates. And I don't know whether they're not able to obtain a cross certificate from another CA, or if they're not wanting to, but this creates implications for interoperability when you think about this. And yes, it's terrifying, and I don't know how much more I can say about that, but this affects your PKI profile and design, because you have to think, how will you change the set of CAs that you trust over time between devices? How will you manage that migration? If you don't allow cross-signing, that makes it much harder. But if you do allow cross-signing, that adds a host of complexity to your security and threat model, because you allow the introduction of entities that you may not have vetted and that may not be part of your threat model. PKIX allows for both scenarios. It doesn't really tell you which is the right or wrong way, and that's both its strength and its curse. Next slide. So yeah, apparently I just covered most of this, so I probably should next slide. I mentioned in the case of like ETLS, and this is also true in the case of mutual TLS, that you have to think about how the certificate paths are going to be built, and whether what the client builds is going to be what the server agrees on. Recall that in that X509 v1, the assumption here was that the directory would be the source of truth. Everyone would always have connectivity to the directory, or at least enough connectivity that they needed, and that you could discover the paths through the directory, both forward and reverse. And so you could build a path that you would be sure that your peer would accept. Fortunately or unfortunately, depending on your take, the directory never materialized, and we had a lot of alternative stuff. LDAP is certainly an option, but I'm happy to tell you most web browsers do not implement LDAP in all of its complexity. So it's not an option for, say, the web PKI. It might be an option for your PKI. It depends on what you're doing. If you're doing it over LDAP, probably. If you're not building an LDAP client, probably not. So you have to work things. Oh, sorry, looks like we jumped a few extra slides. So yes, audits. Sorry, I looked away. Yes. So one of the important decisions, sorry, you can go ahead, next slide. Slide 34. All right, we're on the same page. Another element to the design of PKI, you have to think about, do you like checkboxes or do you like descriptions? Checkboxes, ISO 17021, ISO 17065. They have good, they give you interoperability, they give you compliance testing. They're terrible for security testing, because you have to list everything bad as a negative test. And frankly, listing everything that can go wrong is a very time-consuming process. You can go for a descriptive type of approach to audits. ISAE 3000 is certainly an approach, not the only approach. These are examples where you have the CA describe the system, how it works, how it's designed, how they meet your requirements. Downside, you have to make a judgment on how well they meet your requirements based on that report. And it's really bad for interoperability and compliance testing, because just because something sounds good doesn't mean it'll actually lead to good results. But the answer here for what's the right way, it's going to depend on what you're trying to do. Also with audits, next slide, you have a whole host of questions. This is the auditing practice in general. If you're trying to certify something as compliance, certifying something as interoperability, everyone has to go through this and think about this. Even if you are going to run the PKI yourself and every other vendor is going to trust you to do that, you're probably going to have audits, because they're going to want to know, why should they trust you? And so these are still questions you have to work through, which is talking about, what are the criteria, who decides the criteria, who performs the audits, who decides who performs the audits, how do you know who's performing the audits is good enough to perform audits? It's turtles all the way down, it's trust all the way down. And yes, it ties to a lot of civil legal obligations depending on how you're doing it. If you're doing an ISO 17065 type system, you might not have a legal backing to do. If you're doing ISA E3000, you might have international treaties that can help you. It really depends. Next slide. So I'm trying to rush through and be sensitive to time. So conclusions, last slide. One more slide, 37? Yeah, there we go. The reason for this is to try to highlight that there isn't a single internet PKI and that there really can't be just one internet PKI, because different security protocols are going to require different needs. We don't really think of one cipher suite to rule them all. And while we use SSL TLS ubiquitously, our needs and our capabilities for our clients, from the small end devices to our watches to our high end devices, are vastly different. And our PKI design fits into the security guarantees. So RFC 5280 gives you a framework. I'm very supportive of it. I love it. But it's the tools to build a car, a pool, or a house. And you have to make sure you don't build a floating RV. You can do that, but you shouldn't. It is possible to build interoperable PKIs that work out of the box. It's a lot of work. The web PKI has taken tremendous amount of effort, and each of these questions are still questions that the web PKI is grappling with. It also means that the answers may not be what you need for your use case. And in fact, more often than not are not, which is why I say don't use the web PKI, because when there are these differences, you potentially get broken, and this creates conflict. It creates conflict in security policy, and it creates conflict in, I hate breaking things. Everyone hates breaking things, and these are things we should try to avoid. When you start thinking about a PKI, you really need to ensure that every single byte is critically necessary. You can't leave anything underspecified, because every area that is left for extensibility has turned out in almost every PKI to be a pain point that bites us in the end. Maybe that's not as important if you're doing a small enterprise PKI or just a locally enterprise PKI where you manage, say, 1 million devices. But when you think about interoperability, you have to think of PKI-like protocols and realize that there's not a one-size-fits-all. And when you're doing protocol designs, this is, I would argue, a mistake of SSL TLS, a mistake of Netscape's assumption that has lingered on with us. Consider supporting multiple PKIs. SMIME is good at this, right? You can have multiple signatures. SSL TLS is awful at this because you have the certificate. PKIX somewhat imagined the idea that you could branch the PKIs at the issuer certificate, right? The client can build a different path to a local trust anchor than what the server provided. And for many clients, that's what they do. But there's not a way to provide different certificates themselves that meet different policies in a way that's interoperable. I'm excited still for the certificate frame, like in HTTP2 layer, to allow this provision of multiple certificates. But as you think about protocol designs, design for multiple PKIs, because different vendors, even if they're using the same protocol over the same port, will have different needs. Thinking again, like of the set-top box versus web browser. So I realized that was a little bit of a disconnected talk. I realized there's certainly history that a number of people were participating in. But I'm hoping this gives an insight into sort of what the web PKI is and why it may not be appropriate for the use case, or if you want a PKI, what the challenges are to actually get there and try to replicate the success of an out-of-the-box PKI that just works. And I will shut up.
Yeah, so thank you very much, Ryan. That was a very fun talk and hopefully enlightening in some parts. I know we had a good bit of chat in the Jabber about the specifics of the history, and history is, of course, always hard to get right, especially if you were not there when it happened. So I think we may have extracted a promise from Phil to try and produce a version of the PKI history, which will be very interesting to many of us. I don't know if he wants to try and give some key points right now, or if we should just wait to do that later, because I will try to focus my enthusiasm, I guess, on sort of the last part of the talk about what the operational needs for building a PKI are, and especially even on this last slide, that there's not a single PKI, and that you may need to do your own thing if your needs are different from those of the WebPKI. So I'm very happy that you were able to sort of make that point and really hammer it home throughout with the insights about the WebPKI and other things as well. So I think we can open up the queue for questions and comments and corrections. I know you had asked at the start for corrections as appropriate. So I think we have Phil in the queue. Please go ahead.
Okay, I'm on then. Yeah, I won't go into the history except to say that I don't agree with pretty much all of what was said on the history. I think that one thing that's critical to remember is that the reason that Netscape 1 didn't have certificate chains was that it took an appreciable number of seconds to connect up to a website with SSL in those days, with the machines of the era. And a lot of constraints that we have in PKIX have to do with the constraints that were present in the 1990s and also in the 1970s when Lauren Kohnfelder originally wrote his undergraduate thesis, which is what PKIX is all based on. And so it's not surprising it doesn't work very well. I do endorse the conclusion. I mean, certificates expire, and that is not always what you want them to do. It's particularly not something that you want Internet of Things to be doing in general. It's not, if you look at the design of the RPKI, I mean, trying to squeeze that into PKIX, it was nothing inappropriate technology. What you have there is a registrar who is registering blocks of IP address space. That is something, one of the few things that blockchain would have been useful for, or rather take out the, the silliness of blockchain and go back to harvesting logs. But we've got this hammer, and everything tries to use PKI, and it's not using the things we want. And I don't do PKI. So, anyway, that's my take on it.
Thank you. And we do look forward to hearing the true history. So yes, David, please go ahead.
Thank you. I just wanted to sincerely thank Ryan for this talk. I personally think that we don't have enough historical talks at IETF, and it's kind of, we're all caught in the moment of what's the next best thing or next thing we're building, and having kind of that context is really helpful. So honestly, thank you. I learned a huge amount today, so thanks. That's it.
All right, David, I think you have to manually take yourself out of the queue. I don't believe I have an option to do that for you.
Yeah, and you can if you click the hand, but I can do it as well.
Okay, so Phil, I don't know if you're still intending to be sending audio and video, but Fraser is next in the queue.
Thank you for your presentation. Just wonder if you could briefly talk to the topic of grease. Just in the final slide, you say it's hard to apply to PKIs. Could you elaborate?
All right, audio is sending. Yes. The reason why I say this is grease is hard because you need the cooperation of the CA. And so depending on your model, you may not be able to easily grease things. Now, when you grease things, you need someone to get a certificate, and you need them to send that certificate to someone else. And so this is a three-party coordination problem that makes it very hard to add this grease in, and also makes it hard to randomize a lot of this, because if you start adding, say, extensions to make sure that your extensibility maintains. And using TLS as an example, because you can only send one certificate, you sort of get an all or nothing shot. If that certificate fails, you've now broken the protocol for your peers and you have to get another certificate, and you may not know you broke them. It's a little bit easier, say in something with SMINE, where you could add a regular certificate and a greased certificate and hope you sort of get at the right results. But because it requires the coordination of multiple parties, and whether you're thinking of cross certificates and sort of the classic PKIX model, or you're thinking of the very narrow case, whether it be web PKI or say an even localized part, the multi-party coordination makes it hard for a single party to say, I want to grease things. You need, say, a CA that's willing to give you a grease cert, a server that is willing to take the risk of a grease cert, and you need clients who are willing to allow grease certs to be issued, depending on their compatibility and security needs. So yes, apologies for not going into the greater length there.
Great. So I think the queue is showing up as empty. We have a number of people in the chat thanking Ryan as well for the talk. So I will echo that again. Thank you. I really enjoyed the talk. So I guess, Roman, we have to switch slide decks in order to get to the one remaining slide in share slides, which is, of course, the open mic. So we've got a decent bit of time left. The mic queue is open. Kirsty, please go ahead.
Hi, yeah, thanks for the interesting talks today. I think they've been really good. I just wondered if we could use this time to talk about the vulnerability disclosure policy that the IETF is, or IESG is soon to publish, and any sort of timescales for revisions, or yeah, if you could just speak to a bit about your future plans for it, because I think, as Roman said yesterday in the IESG, there's work to do, and kind of how to best harness the expertise that you have in IETF to make it the most effective it could be. Thank you.
Great question. I think what we're about to publish is documenting the as is on the ground. It makes no attempt really to change any behavior in the IETF other than adding really kind of the alias. As folks have commented on the list, and as you kind of well know, what we're describing is pretty far from what best practice would be if you were certainly kind of a product vendor or anyone dealing in this class of coordination. We should be trying to optimize to make it as easy as possible to get those reports, and providing as much support to those reports in working them, in triaging them and working them through the entire organization. And the current process, frankly, doesn't do that. I think that to pivot what we do now to be a little closer to best practice, it's going to require work on kind of consensus building to have and work vulnerabilities in a I guess a more centralized way. I think the other kind of component to that is we should probably eat a little bit of our own dog food. We have security.txt almost kind of published. We should make sure when that's officially kind of published that's something we serve for kind of the IETF. So I think a lot of dimensions of that are on deck. Personally, I think we're going to have to nibble at it, a little bit at a time. One of the other best practice things we as the IETF need to figure out we have appetite for is how much, if at all, we want to engage the implementation community to make sure they are aware of fixes we make to our documents that address kind of security issues that they may be implementing.
So I guess, Roman, to have a little bit of a follow-up question for that, are these evolutions and improvements something that you plan to be driving, or do you think there's a space for someone else to be sort of taking the lead in those conversations?
I mean, I definitely think we're going to need a community-based approach. I think one of the things that came out of the feedback is, do we have a reasonable place to talk about what that future would look like? And I think it made a ton of sense to create a mailing list, to have that conversation.
Yeah, thank you. I think that that's a really good approach to go forward, to create a mailing list and start discussions, because it would be keen to see it move forward. Thanks.
Dave,
Okay.
you're up.
Hi. So I think have you considered, so one of the things I do outside of the IETF is I work within the CV community as a CV board member. And, one of the things that we're trying to do in CVE is we're trying to recruit additional organizations that are CV numbering authorities, organizations that are able to assign on their own CV IDs to things that are vulnerable. Has the IESG thought about maybe becoming a CVE numbering authority as part of the CVE program? This is an interesting use case that we haven't really explored too much within CVE, but you could effectively issue CVIDs against RFCs, and those could be referenced by potential implementers.
Yeah, I mean, that's certainly kind of a good point. We haven't talked about that in the IESG, but that's come back as feedback that's something the IETF can do. I think that's great kind of fodder for how much appetite there is to do that, in further kind of discussion. I mean, I would just say what we have now was not attempting, again, to be as ambitious as that, and we would have to figure out quite a lot of workflow things to do that. But I mean, there's no reason why we couldn't. I mean, frankly, kind of scoping on what we would hand CVs out for and having confidence in how consistent we are about handing those out would be kind of key challenges I would see on deck if we were to head that way. But yeah, good point.
Yeah, and if there's interest in doing that, I would be certainly willing to help, however I can.
Yeah, thanks.
You're welcome.
Okay, Phil, back up.
Hello, can you hear me now?
Yes.
Yeah, you're good.
Okay, so I just wanted to say, so blockchain is currently the hot topic in crypto. I would urge people to take a look at what's starting to come out of the threshold cryptography world. There's just been a NIST workshop on threshold cryptography, and the next administration in the US is going to be dealing with the consequences of the Snowden breach and insider threats and a whole rack of other security issues for which threshold is the obvious technical solution. So I've made a set of training videos to show you how threshold is working inside. I'm afraid they're not up yet, but I will edit them in the next few weeks and put them up to help people get up to speed. And those will all be on YouTube. Thanks.
Thanks. Please do post the links to Saag when they are up. I'm sure it will be an interesting topic for us, and I agree that we should start using those technologies. Okay, this is still the open mic, but the queue is showing up as empty. So I will start the internal countdown for the last call for open mic comments. Okay, we have Chris. Please go ahead.
I'll voice what I commented in the Jabber platform, kind of seconding support for automatic ways to acquire vulnerabilities about RFCs. I can picture a world in which I can mark tools that I have written as implementing or relying on specific RFCs, and then automatically inherit CVEs or whatever vulnerability disclosures happen in a way that my tooling can help me manage. I can even see a world in which systems like GitHub or GitLab provide this to people. And obviously the implementation is far out of scope here, but if we provide that in a tool digestible way, I think we have some opportunities here to improve security in a fairly sizable way.
Yeah, thanks for that feedback. If we ultimately decide to go that way, absolutely. I mean, exporting that in some machine consumable way and having that as metadata in the data tracker seem like obvious kind of ways to export that information for the community. Thanks.
Yeah, I think there'd have to be CVEs that are directly specific flaws in the RFC or related to it, or lack of clarity. There's a lot of potential complexity that's worth pursuing.
Right, it's certainly not simple. But there have been specific vulnerabilities in the RFCs itself and not just implementations thereof, right?
Yes.
And so
Okay, DKG, I guess you're up.
Thanks. I am more wary about the idea of assigning CVEs to RFCs. I understand the impulse, but I think most of the vulnerabilities that we're concerned about are either in a specific subsection of an RFC, which any given piece of software might or might not implement, or they are about how certain RFCs are used in the world, in which case it's not clear whether your particular tool is going to tickle that particular problem, or the problem is between the intersection of two different RFCs, right? When you run HTTP 1 over TLS 1.0, what are the issues versus if you, right? I mean, if you're doing this particular kind of DNS lookup while talking to XMPP services, right? I mean, this is where some of the problems that we run into are, and I don't see how we can adequately represent that in a way that a machine can consume it, unfortunately.
Chris, did you jump in the queue to respond? So please go ahead.
Indeed, I did. I think this is a common problem with CVEs and is absolutely not unique to RFCs in any way. The CVEs that I see frequently when I look at CVEs against dependent libraries, very, very frequent, in fact, most of the time, those CVEs are not indicating a vulnerability in the way I'm using that library. And the same is going to be true about RFCs, right? If there's a vulnerability that only has to do with certain implementations and use cases, and the tool that implements this particular RFC doesn't tackle that particular issue, as he said, then yeah, it's not going to be a particular issue. But I don't know that particular piece is either A, actually possible to solve, or C, or B, something that we need to solve. Because this exact same problem happens in lots of other places, and it doesn't prevent us from producing these easily digestible mechanisms.
Yeah, absolutely. And the other bits of feedback that have come in as the CVE topic for RFCs have come up is a reminder that RFCs come in a lot of flavors. I mean, some of them are protocol specs, some of them document operational practices. And to the question of dependencies, we have RFCs that do updates on other kind of RFCs. And so when you tag something, it could mean a lot of different things, but concur that it's quite similar to the current software ecosystem as well. Yeah, that's why we need the conversation in the mailing list. Thanks.
Okay, Dave, sorry to skip you.
So the CV program is actually working. They have an existing CV record format that describes a lot of metadata about a vulnerability. We're currently in the process of revising that format. The previous format was version 4. We're working on version 5 right now. And part of what we're trying to do is add a lot more contextual metadata. This problem of how do we identify the interaction or the aspect of a given protocol or library that's vulnerable has definitely come up in that situation. That's something that we're interested in solving, either in version 5 or in subsequent version. I would recommend that this community not go off and create an additional record format for representing a vulnerability. There's already a plethora of those out there today. But it would be great if we could find a way for this community to work with the CVE program to solve these problems. Because then we could actually produce a more robust record format for describing a vulnerability in a way I think that could serve this community as well as all of the other communities served by CVE. I'd be interested in exploring that. Maybe I should post something to the list.
Yeah, definitely. If there's a forum where people can engage with the CVE maintenance community. Sorry,
Yeah.
Roman.
So, Dave, I was going to say follow-up question. Is the CVE program have other SDOs that are on board as well?
No, I mean, this is kind of a new space. There's not a lot of SDOs out there that are there's no SDO that's a CNA right now. And so any protocol vulnerabilities that have been issued a CVID was done by the CNA of last resort, which is operated by MITRE. And so this is new ground, looking at an SDO actually issuing CVIDs. And so because it's new ground, we're going to have to work through some of these issues.
Thanks.
Okay, Joe, I think you're up.
So I think, the CVE format as it stands now, or, the information contained isn't perfect, but it's still really useful, right? And some things you can do, through automation, but there's a lot of things that still you might not be able to because of either the quality of information in the CVE or lacking some details. And it's really encouraging that there's, continuing work going on here. And I think it would be worthwhile to see, how we could link up with that, because I think it would be better not to create yet another format. But I think some of the value that we would provide is just thinking through, what are the things that we want to have, associated with it, and vulnerabilities that are in RFCs, and what counts as a vulnerability in RFC versus, implementation vulnerabilities that are not really protocol vulnerabilities, but it still maybe help to have those associated, and categorized in that way, both for somebody who's looking for issues and for our own information when we go back and look at, well, which protocols have had problems and why. I think it could be really useful.
Yeah, so I guess we are looking to Dave to sort of give us an email that tells us where we should be talking about these things, if there's a good forum at the CVE side. And of course,
I'll certainly do that.
Yeah, if you need a mailing list, IETF hosted mailing lists are cheap and easy.
Thanks.
The good place of synergy might be the new mailing list we'll create, kind of regardless of that class of coordination.
Okay, so Hannes, I think you're up.
Yeah, in the OWASP working group, we looked at various security incidents and related to OWASP, and many of them were actually fairly complex. And so I'm trying to see how that disclosure process would actually work in practice with IETF protocols, because first we had the problem to actually even learn about the incident. at the level of detail that we could make an assessment of what was actually the problem, which is often a challenge. You hear that, oh, there's a problem with OAuth, but you don't get to know like what was really the setup. And then some people extend it, take shortcuts, and or modify the protocol or use it in an unexpected way. And understanding all of this requires a lot of time. You know, sometimes we are talking about months here if you try hard. And so I wonder who is then actually asked to do that, to really say like, what is the problem? What do we need to do? It sounds very challenging. It sounds like a good idea in theory, but in practice, it's really tough.
Respond, kind of, Hannes, no question that there's a complexity in overlaying the kind of coordination process on how we do things in the IETF, minimally not to kind of break anything, but some of the feedback I've at least heard on the value mentioned kind of here and in previous conversations is that, you know, as we think about folks coming to our documents, would there be some easy way through the CV process to just kind of signal to implementers that there are kind of issues with kind of metadata, and you know, so that could be one thing that's done. And you know, Hannes is also being modest. I wanted to reiterate in making the text for that we're about to kind of publish. I surveyed practices across the IETF that were published for vulnerability disclosure, and OAuth is the only working group, active working group, and closed working group that I could find that by charter had actually taken the time to publish how they would handle the injector vulnerabilities. So kind of kudos to the current OAuth chairs and the foresight of the previous ADs and chairs who did the chartering.
Yeah, I guess just to follow up on one semi-related point, you know, if there is going to be a very long, extended process to figure out what exactly the vulnerability is, it seems almost certain that, you know, the working group itself is going to have to get involved with that. And you know, I know if you're talking about confidential disclosure, that may not always directly be applicable, but I think that the way that IETF operates with generally open and community participation, you know, we're going to have to get to the working group at some point. Okay, Chris, you are back.
Yeah, I was just going to point out that this inevitably there will be disclosures filed against working groups that are now have completed their work, and so we'll need to make sure there won't always be a live working group to handle the situation.
Yes. Sean, go ahead.
Hey, so that makes me think about trying to resolve errata from closed working groups. It's really difficult to get the smallest things fixed. If you're trying to resolve a CVE against a long closed working group, I mean, good luck. It's going to be very difficult to do that. I guess the other thing I'll add is that at one point I was being copied on a lot of vulnerabilities for a particular working group that I was a chair of, and I basically told them to stop copying me because there was nothing I could really do with it, and I was really concerned about trying to maintain the confidentiality requirements, and there was like, you know, you can talk about it now, you can't talk about it then, and I was like, I really don't need to know about this. This sounds like an implementation problem. When you guys have come to an agreement and fix it, that's great. Please come to the working group and tell us about it later. So it's definitely some things you're going to have to think about how to work through.
Dave, go ahead.
One of the things we're trying to dispel in CV is this notion that every vulnerability needs a fix. It's possible to publish a vulnerability, you know, without any fix. And so, you know, one advantage of doing something like that is it could be a further motivating factor for implementers to move away from older protocols that have a lot of inherent vulnerabilities to newer versions that don't have those vulnerabilities. So if there isn't a working group and the protocol is, the community is working to try to move on from that protocol, issuing a CVID for something that isn't fixed could be a potential motivator to get implementers to upgrade. So that's something else to think about here.
Yeah, it makes sense.
Hannes, go ahead.
Yeah, just to give you an example of a problem we ran into was OAuth uses the JSON Web Tokens, and that work was standardized in the IETF, and there were lots of libraries available that produce these JWTs and the corresponding security mechanisms. But what many implementers did was they didn't include sort of code for the policy handling. So if you included an algorithm that was completely insecure, like a null algorithm, then the software, if you didn't pay attention, would just accept that. You could basically modify the tokens in the way you like it, by just saying none, and then there's no signature protecting it, and so on and so on. So obviously a problem. Is it a problem with the RSC? Not to a certain extent. Like maybe there should be no such algorithm in the first place. But that aside, we then wanted to reach out to the guys who wrote those libraries, and it turns out that this is also extremely difficult, because the ecosystem is, for some of our protocols, so huge. We don't know who is implementing even a fraction of it. And then those people deploying it is like a completely different story. So if we find a vulnerability and know it, and then describe it as well, and then make it available with an inability to actually reach out to the implementers of those libraries or to the people who deploy it, actually we make the situation potentially worse than before. So just saying, oh, move on to something else, I think is not always a good approach, because our work starts quite early. We move on, we always go to the next, the shiny new thing, but implementers need a lot of, on deploying community, need a lot of time, and they deploy technologies that we worked on like 5 or 10 years ago. So it's really tricky to do that. And so I wish sometimes there were fewer implementations, but just better maintained, because people move on and leave the code out there, and it's actually a ticking time bomb.
Yeah, that's good caution. Thank you, Hannes.
Yeah, it ties into sort of responsible disclosure for vulnerabilities in general, and trying to figure out how to do the right thing can vary on a case-by-case basis. Dave, you're back.
Honest to think about though is that so I completely agree with what you're saying, and that's certainly a classic problem in this space. Another advantage of publishing a CVID would be also a mechanism to publish guidelines around how to mitigate a given vulnerability. So where there are existing implementations that are vulnerable and it may be difficult to replace them or upgrade them, or whatever the more ideal path would be, it might be an opportunity for the IETF to publish guidance on how to put in place compensating controls, or other things for both implementers and users to consider, to reduce the the risk of the vulnerability being exploited. So it could be used as part of an awareness campaign to support that type of activity too.
Yeah, agreed.
And as we leave the queue open, I do want to note that we have had some notes being taken in the CodeMD, and Thank you very much to whoever's doing that. Please leave your name at the top as having contributed to the minutes, and then we can thank you properly when those get sent out. And as the queue remains empty, we have 6 minutes left in our time slot, so we are kind of approaching the end regardless. All right, the queue is still empty, so I think we should call it. Thank you everyone for attending. Thank you, Ryan, for the talk. Thank you for the excellent discussion on all the points that we had. And we've got some follow-up work for us to work on. So this was a good meeting. Thanks everyone, and we'll see you in Gathertown.
Take care, everyone.
Bye.